Hi, space explorers! Welcome to Funimation 3D, where big science becomes a fun adventure, and the universe feels like a playground you can actually understand. Now here's a quick mystery for you. If stars are giant glowing balls in space, how do they get started? Do they just appear one day like ta-da? Or do they grow step by step like a baby animal? Today we're exploring the birth of stars, how stars are born in space. And by the end, you'll know exactly how a star goes from a quiet space cloud to a shining superstar. First, what is a star? A star is a giant ball of super-hot gas that makes its own light and heat. Think of it like a cosmic flashlight that never needs batteries, at least not for a very, very long time. And guess what? Our sun is a star. It's the closest star to Earth, and it keeps our planet warm enough for trees, oceans, and yes, ice cream days. Quick question, if you could safely high-five the sun with the world's strongest oven mitt, would you do it? So where do stars come from? Stars are born inside something called a nebula. Say it with me, nebula. A nebula is a giant space cloud made of gas and tiny bits called cosmic dust. And cosmic dust isn't the dusty stuff in your house. It's more like tiny, sparkly crumbs of space material, the building blocks the universe uses to create amazing things. Nebulas are even nicknamed star nurseries because baby stars begin there. Imagine the universe has special baby rooms, and nebulas are the biggest ones. If you could paint a nebula any color you want, what colors would you choose? Tell me in the comments. Rainbow Nebula fans, I see you. Now comes the star-making superhero, gravity. Gravity is the invisible force that pulls things together. It's why you come back down when you jump, and it's why your backpack doesn't float up to the ceiling. In space, gravity is how a cloud of gas can slowly turn into a star. Inside a nebula, gravity begins giving the gas and dust a big squeeze, like gravity hugs. At first, the cloud is spread out, but then tiny bits start to clump together. Those clumps pull in more gas, and bigger clumps pull in even more. It's like rolling a snowball. Start small, roll it around, and suddenly it's huge. Have you ever watched a bunch of kids gather around the same toy? Gravity is kind of like that. Everything slowly gathers in one place. As gravity keeps hugging tighter, the middle of the cloud becomes a crowded, busy place. Gas and dust bump into each other more and more. Bonk, boop, bump, and all those bumps create heat. The center starts to get warmer and warmer, like a toaster that's just starting up. This almost a star has a name, a protostar. A protostar is a baby star warming up. It's still collecting gas from the nebula, still growing, still heating up, still getting ready. What do you think a baby star would sound like? A tiny pew-pew, a soft or a dramatic da? Drop your best guess in the comments. Now we're getting close to the big moment. As the protostar grows, gravity squeezes the center even harder. The core gets hotter and hotter until something incredible begins. Inside the core, the star starts a powerful process called nuclear fusion. That sounds like a robot word, so here's the kid-friendly version. Nuclear fusion is the star's tiny energy factory. It takes a gas called hydrogen, the star's main ingredient, and presses it together so tightly that it turns into helium. Hydrogen becomes helium. And when that happens, it releases a huge amount of energy, light, heat, power. This is the star switch moment. Not like a bomb explosion, more like a giant cosmic lamp turning on for the very first time. And now the star is truly shining. Here's the coolest part. The star stays steady because two forces balance each other. Gravity pulls inward like a squeeze, while the star's energy pushes outward like a puff of air. When the pull and the push balance, the star holds its shape and keeps glowing. It's like a tug of war where nobody falls, perfect cosmic teamwork. If stars could talk, do you think they'd say "I'm glowing" or "I'm working"? I think they'd say, "I'm busy being awesome." Now, not all stars grow up the same way. Some baby stars collect less gas and become smaller stars. They burn their fuel slowly and can shine for a very, very long time, like a gentle nightlight that lasts and lasts. Other baby stars collect a lot of gas and become bigger stars. They burn brighter and faster, like a giant stadium spotlight. So stars can be small and steady or big and bold, depending on how much space stuff they gather while growing. Which would you rather be, a small star that's calm and steady, or a big star that's super bright and bold? Comment small star or big star and tell me why. All right, quick recap. Stars begin in nebulas, which are giant clouds of gas and cosmic dust. Gravity pulls that stuff together with gravity hugs. A protostar forms, a baby star warming up and growing. When the core gets hot enough, nuclear fusion begins, turning hydrogen into helium and releasing tons of energy. The star switches on, balances push and pull, and shines in space. So the next time you look up at the night sky, remember, every star you see has a beginning. It started as a quiet space cloud, then gravity gathered it up, then a baby star warmed up, and finally, the universe's coolest energy factory turned on. What's your favorite part of star birth? Nebula colors, gravity hugs, baby protostars, or the fusion lamp turns on moment? Tell me in the comments. Thanks for exploring with us on Funimation 3D. And don't forget, like, share, and subscribe to Funimation 3D.